In this chapter, we're going to tackle about problem solving. To start, for introduction, one of the leading mathematicians to make a study on problem solving was George Polya. He was born on 1887 and died 1985. He was born in Hungary and moved to the United States in 1940. George Polya, after a brief stay at Brown University, moved to Stanford University in 1942 and taught there until his retirement. While at Stanford, he published 10 books and a number of articles for mathematics journals. Of the book Polya published, How to Solve It on 1945 is one of the best known. In this book, Polya outlines a strategy for solving problems for virtually any discipline. So, for our objectives, at the end of the lesson, you should be able to number 1, translate mathematical symbols to expression and vice versa. Number 2, discuss the language, symbols, and conventions of mathematics. Number 3, solve problems involving patterns and recreational problems following Polya's 4-step. And number 4, organize one's methods and approaches for solving problems. So, for our lesson, problem solving and problem solving strategies. Polya's 4-step problem solving strategy. Number 1, understand the problem. Number 2, devise a plan. Number 3, carry out the plan. And number 4, review the solution. Number 1 is understanding the problem. On this step, you may restate the problem, determine what is known and unknown, and identify the goal of the problem. Number 2 is devising a plan. On this step, you must be able to identify an appropriate strategy or strategies to solve or to answer the unknown of the problem. Consider the following strategies. Number 1, draw a diagram, table, or chart. Number 2, make an organized list that shows all of the possibilities. Number 3, work backwards. Number 4, look for a pattern. Number 5, write an equation. If necessary, define what each variable represents. Number 6, inductive method. And number 7, deductive method. Find the condition between the data and the unknown. You may be obliged to consider auxiliary problems if an immediate connection cannot be found. You should obtain eventually a plan of the solution. Number 3 is carrying out the plan. Once you have devised the plan, you must carry it out. In short, perform your plan. On this step, you must be able to respond to the question or questions asked. Number 4 is looking back. Can you check the result? Can you check the argument? Can you derive the result differently? Can you see it at a glance? Can you use the result or method for some other problem?
First topic under the problem solving is the number problem. In number problems, there are one or more numbers serves as clues. And these clues can be used to build an equation, then find the value of the unknown variables. Number problems having one unknown. 1. Represent the unknowns by variables. 2. Translate relationships among the unknowns into equations. 3. Solve the equations to find the values of the unknowns. 4. Check or verify the values found to see if they satisfy the original problem. Example 1. If a number decreased by 5, the result is 28. What is the given number? Solution. Let n equals a given number. N minus 5 equals 28. In order to get its value, in the given n minus 5 equals 28, the 5 will be moved to the right and the sign change from negative into positive. And it is now n equals 28 plus 5 will be equals to the answer which is 33. Example 2. 3 times a number increased by 8 equals 41. What is the number? Solution. Let n equals a number. 3n plus 8 equals 41. We need to move the 8 again into the right and change the sign from positive into negative, and it will become 3n equals 41 minus 8. 3n over 3 equals 33 over 3. Cancel out the 3 and it will become n only. Then 33 divided by 3 will be equals to the answer, which is 11. Example 3. A number added to 1/4 of itself equals 45. What is the number? Solution. Let n equals a number. N plus n over 4 equals 45. 4n over 4 plus n over 4 equals 45. 4 over 5 times 5n over 4 equals 45 times 4 over 5, and n is equals to 36. Example 4. 15 is the sum of 1/4 of a certain number and 3/8 of the same number. What is the number? Solution. Let n equals a number. 1/4 n plus 3/8 n equals 15. 2n over 8 plus 3n over 8 equals 15. 5n over 8 equals 15. 8 over 5 times 5n over 8 equals 15 times 8 over 5, and n is equals to 24. Number problems having two unknowns. Example 1. One positive number is twice another. The larger is 10 more than the smaller. Find the number. Solution. Let S is equals for the smaller number, L for the larger number, L is equals to 2S, L equals S plus 10. Substitution. 2S equals S plus 10, 2S minus S equals 10, S equals 10, L equals 2S, L is equals to 2 times 10 equals 20. Answer. The smaller number is 10 and the larger number is 20. Example 2. The sum of the larger and 8 is 3 times the smaller. The larger reduced by 10 equals twice the smaller. Solution. Let S equals for the smaller number, L for the larger number. L plus 8 equals 3S. In L plus 8 equals 3S, the 8 will be moved again to the right and change the sign from positive into negative. L minus 10 equals 2S. Substitute. 3S minus 8 to L in L minus 10 equals 2S. L minus 10 equals 2S. 3S minus 8 minus 10 equals 2S. 3S minus 2S equals 10 plus 8. S is equals to 18. L is equals to 3S minus 8. L is equals to 3 times 18 minus 8 equals 54 minus 8 equals 46. Consecutive integer problems. Kinds of integers. First consecutive number, second consecutive number, and third consecutive number. Consecutive integers are odd or even. N plus 1, n plus 2. Consecutive even integers are even only. N plus 2, n plus 4. Consecutive odd integers are odd only. N plus 2, and n plus 4. Example 1. Find the three consecutive integers when their sum is 21. Solution. N plus 1 plus n plus 2 equals 21. 3n plus 3 equals 21. In the given 3n plus 3 equals 21, the 3 will be moved again to the right and change the sign from positive into negative. It will become 3n equals 21 minus 3. 3n equals 18. N equals to 6, n plus 1 equals to 6 plus 1 equals 7, n plus 2 equals 6 plus 2 equals 8. Example 2. The sum of the first two is 7 more than the third. Solution. N plus 1 equals n plus 2 plus 7. 2n plus 1 equals n plus 9. 2n minus n equals n minus 1. n equals to 8, n plus 1 is equals to 9, n plus 2 equals to 10. Answer, the three consecutive integers are 8, 9, and 10. Example 3. The third added to twice the first is 12 more than twice the second. Solution, 2n plus n plus 2 equals 2 times n plus 1 plus 12. 3n plus 2 equals 2n plus 2 plus 12. 3n minus 2n equals 14 minus 2. N is equals to 12. N plus 1 equals to 12 plus 1 equals 13. N plus 2 equals 12 plus 2 equals 14. Answer, the three consecutive integers are 12, 13, and 14. Example 4. The sum of two consecutive even integers is 94 in their product. Solution. Consecutive even integers can be represented as x minus first even integer, x plus 2 the second even integer. We will get the sum of these consecutive even integers and equate to 94 in symbol. X plus 2 equals 94. In x plus 2 equals 94, combine the variable and constant. 2x equals to 94 minus 2. 2x over 2 equals 92 over 2. Solve for x by dividing both sides by 2. X equals 46. The first even integers is x equals 46. The second even integer is x plus 2 equals 46 plus 2 equals 48. And therefore, the product of two consecutive integers is 46.48 is equals to 2208. Example 5. The sum of three numbers is 58. The second number is 4 more than the first number and the third number is 8 more than the second number. What are the numbers? Solution. We will represent the following numbers as follow. X will be the first number. X plus 4 will be the second number. 4 more than the first. X plus 4 plus 8 will be the third number is more than the second. Let us represent the sum of the three numbers as x plus 4 plus x plus 4 plus 8 is equals to 58. Given x plus 4 plus x plus 4 plus 8 is equals to 58, combine the variables and the constant will become 3x plus 16 equals 58. Simplify further, 3x equals 58 minus 16, 3x equals 42, 3x over 3 equals to 42 over 3. Solve for x, divide both sides by 3, will be x equals to 14. The three numbers where x equals 14 will be the first number. X plus 4 equals 14 plus 4 equals 18 will be the second number. X plus 4 plus 8 equals 14 plus 12 equals 26 will be the third number.
Good day everyone, I am Arjeline Cortel from BSED 1D. Today, I'm gonna discuss to you how to solve age-related problem solving. In solving age problem, there are two rules that we needed to follow. So rule number 1, to find a person's future age a number of years hence, add that number of years to his or her present age. Rule number 2, to find a person's past age a number of years ago, subtract that number of years from his or her present age. So the rule simply says that in order to find a person's future age, you needed to add. And in order to find a person's past age, we needed to subtract. So we have an example here. Example number 1. The sum of their present ages is 40. The father is 20 years older than the son, so find their ages. Solution. Let S be the age of the son and let S plus 20 be the age of the father. So we will add the age of the son to the age of the father. So it will be S plus 20 is equals to 40. And we will combine similar terms. 2s is equals to 40 minus 20 will give us 2s is equals to 20. And in order to eliminate number 2, we will divide both sides by 2. 2s is equals to 20 or 2s over 2 equals 20 over 2 will give us s is equals to 10. Therefore, the present age of the child is 10 years old. So now that we know the present age of the child, we will substitute it in order to know the present age of the father. So s plus 20 is equals to 10 plus 20 is equals to 30. Therefore, the present age of the father is 30 years old. So if we will add the present age of the son to the present age of the father, it will give us the sum of 40. And as you can see, the father's age is 30. Therefore, he is 20 years older than his son. So let us move forward to example number 2. The sum of their present ages is 50. So in 5 years, the father will be 3 times as old as the son will be then. Find their ages. So there is a table to clearly show our solution. The son's present age is represented by letter S, and the father's present age is represented by letter F. And the equation for their present ages is represented by S plus F is equals to 50. The son's age in 5 years is represented by S plus 5, and the father's age in 5 years is represented by F plus 5. And the equation for their ages in 5 years is represented by F plus 5 equals 3 times quantity S plus 5. S plus F is equals to 50 is the same as F is equals to 50 minus S. F plus 5 is equals to 3 times quantity S plus 5. So we will substitute 50 minus S to F in F plus 5 is equals to 3 times quantity S plus 5. So it will be F plus 5 is equals to 3 times quantity S plus 5. Then it will be 50 minus S plus 5 is equals to 3S plus 15. So we will combine similar terms. 55 minus 15 is equals to 4S. So it will be 4S is equals to 40. So we will divide both sides by 4 to eliminate number 4. 4S is divided by 4 equals 40 divided by 4 will give us S is equals to 10 or 10 years old. So the son's present age is 10 years old. So now that we know the present age of the son, we will substitute it to know the present age of the father. So F is equals to 50 minus S equals 50 minus 10 is equals to 40 years old. So the father's present age is 40 years old. So for us to know their ages in 5 years, so we will substitute 10 in S plus 5 for the son's age. So it will be 10 plus 5 is equals to 15. Therefore, the son's age in 5 years is 15 years old. And for the father, we will substitute 40 to F plus 5. So it will be 40 plus 5, so the father's age is 45 years old, making the father 3 times as old as the son will be then in 5 years. So let us move forward to example number 3. Jose is 10 years older than Carlo. 12 years ago, Jose was 3 times as old as Carlo was then. Find their present ages. So there is also a table. So Jose's present age is represented by letter J, and Carlos' present age is represented by letter C. And the equation for their present ages is represented by J is equals to C plus 10. Jose's age 12 years ago is represented by J minus 12, and Carlos' age 12 years ago is represented by C minus 12, and the equation for their ages 12 years ago is represented by J minus 12 equals 3 times quantity C minus 12. So we have two equations. Equation number 1, J is equals to C plus 10, and equation number 2, J minus 12 equals 3 times quantity C minus 12. So we will substitute C plus 10 to J in J minus 12 equals 3 times quantity C minus 12. So it will be J minus 12 equals 3 times quantity C minus 12. It will be C plus 10 minus 12 equals 3 times quantity C minus 12. C plus 10 minus 12 equals 3C minus 36. So we will combine similar terms. 36 minus 2 equals 3C minus C. So it will be 2C is equals to 34. So we will divide both sides by 2 to eliminate number 2. So it will be 2C divided by 2 is equals to 34 divided by 2 will be C is equals to 17 years old. Therefore, Carlos' present age is 17 years old. And now that we know Carlos' present age, we will substitute it in order to know Jose's present age. So J is equals to 17 plus 10 is equals to 27 years old. Therefore, Jose's age is 27 years old. And in order to know their age or their ages in 12 years ago, So for Jose's age, we will substitute 27 to j in j minus 12. So it will be 27 minus 12 is equals to 15 years old. So Jose's age 12 years ago is 15 years old. So for Carlos' age, we will substitute 17 to c in c minus 12. So it will be 17 minus 12 is equals to 5. Therefore, Carlos' age 12 years ago is 5 years old. So Jose's age is 15 years old. Therefore, he is 3 times as old as Carlo was then 12 years ago. So let us move forward to example number 4. So the sum of ages of Christine and Ben is 32. 4 years ago, Christine was twice as old as Ben. How old are they both now? So ages of Christine and Ben is represented as follows. So Christine's age now is represented by letter K, and Ben's age now is represented by letter B. And the equation for their age now is represented by K plus B is equals to 32. Christine's age 4 years ago is represented by quantity K minus 4, and Ben's age 4 years ago is represented by quantity B minus 4. And the equation for their ages 4 years ago is represented by 2 times quantity K minus 4 equals B minus 4. So based from the problem, we have two equations. So equation number 1, K plus B is equals to 32, and equation number 2 is 2 times quantity K minus 4 equals B minus 4. So let us solve the equation. K plus B is equals to 32 is the same as 32 minus K for equation 1, and for equation 2, 2 times quantity K minus 4 is equals to B minus 4. So we will substitute equation 1 to equation 2. It will be 2 times quantity K minus 4 is equals to B minus 4. So 2K minus 8 equals 32 minus K minus 4. So we will combine similar terms. 2K plus K is equals to 32 plus 8 minus 4. So it will be 3K is equals to 36. So we will divide both sides by 3 to eliminate number 3. So 3K is divided by 3 is equals to 36 divided by 3 will give us K is equals to 12. Therefore, Christine's age now is 12 years. In order to know Ben's age, we will substitute 12 to K plus B is equals to 32. So 12 plus B is equals to 32. So B is equals to 20. Therefore, Ben's age now is 20 years old. So to check if our answer is correct, we will substitute K is equals to 12 in the equation. So 12 times quantity 12 minus 4 is equal to 32 minus 12 quantity minus 4. So 2 times 8 is equals to 20 minus 4 is equals to 16. So our answer is correct. So for us to know the age of Christine 4 years ago, we will substitute 12 to K minus 4. So it will be 12 minus 4 is equals to 8. So therefore, Christine's age 4 years ago is 8 years old. And for Ben's age 4 years ago, we will substitute 20 to B minus 4. So it will be 20 minus 4 is equals to 16. Therefore, Ben's age 4 years ago is 16 years old. Therefore, Ben is twice as old as Christine 4 years ago. Okay, let us move to the last example. Example number 5. Brandon is 11 years older than Rhonda. In 7 years, the sum of their ages will be 101. So how old are they now? So solution, ages of Brandon and Rhonda is represented as follows. So Brandon's age now is represented by letter B, and Rhonda's age now is represented by letter R. So the equation for their age now is represented by B is equals to R plus 11. Brandon's age in 7 years will be B plus 7, and Rhonda's age in 7 years will be R plus 7. And the equation for their ages in 7 years is B plus 7 plus R plus 7 is equals to 101. So based from the problem, we have two equations. B is equals to R plus 11 for the equation 1, and B plus 7 plus R plus 7 is equals to 101 for equation 2. So we will substitute equation 1 to equation 2. B plus 7 plus R plus 7 is equals to 101. So we will substitute B is equals to R plus 11. So it will be R plus 11 plus 7 plus R plus 7 is equals to 101. And we will combine similar terms. So it will be 2r plus 25 is equals to 101. And then it will be 2r is equals to 101 minus 25, and it will give us 2r is equals to 76. So we will divide both sides by 2 to eliminate number 2. It will be 2r divided by 2 is equals to 76 divided by 2. It will be r is equals to 38. So Rhonda's age now is 38. So we will substitute it in b is equals to r plus 11 in order to know Brandon's age now. So it will be b is equals to 38 plus 11. So b is equals to 49. Hence, Rhonda's age is 38 while Brandon's age is 49. So to check if our answer is correct, we will substitute x is equals to 38 in the equation. So x plus 11 plus 7 plus x plus 7 is equals to 101. So 38 plus 11 plus 7 plus 38 plus 7 is equals to 101. So our answer is correct because it is equal to 101. So in order to know Brandon's age in 7 years, we will substitute 49 to b plus 7. So it will be 49 plus 7 is equals to 56. Therefore, Brandon's age in 7 years is 56 years old. And in order to know Rhonda's age in 7 years, we will substitute 38 to r plus 7. So it will be 38 plus 7 is equals to 45 years old. And if we will add Brandon and Rhonda's age in 7 years, it has the sum of 101. That is how to solve age-related problem solving. I hope you learned something.
Mixture and concentration. Mixture problems or word problems where items or quantities of different values are mixed together. Sometimes, different liquids are mixed together, changing the concentration of the mixture. At other times, quantities of different costs are mixed together. It is better to use a table to organize information for mixture problems. Using a table allows you to think of one number at a time instead of trying to handle whole mixture at once. The basic structure of the table is shown at the presentation. The first column in the table, the name, is used to identify the fluids or object being mixed in the problem. The second column, the amount, identifies the amounts of each of the fluids or object. The third column, the value is used for the value of each object or the percentage of concentration of each fluid. The last column, the equation, contains the product of the amount times the value or concentration. So let's have example number 1. Joshua has 70 ml of a 50% methane solution. How much of an 80% solution must he add so the final solution is 60% methane? Find the equation. The first solution names are solution 50 for 50%, solution 60 for 60%, and solution 80 for 80%. Now for the amount, solution 50 has amount of 70 ml, solution 80 has amount of N, solution 60 has amount of 70 ml plus N. And for the values or concentration, solution 50 has a value of 0.50, solution 80 has a value of 0.80, solution 60 has a value of 0.60. To find the equation, we'll just multiply the amount of every solution to its value or concentration. So 70 ml times 0.50 is equals to 0.50 times 70 ml. And times 0.80 is equals to 0.80 times N. 70 ml plus N times 0.60 is equals to 0.60 times 70 ml plus N. Therefore, the equation derived from this data is 0.50 times 70 ml plus 0.80 is equals to 0.60 times 70 ml plus N. So for the example number 2, John and Louie have 2 grades of milk from their small dairy herd. One that is 20% butterfat and another that is 18% butterfat. How much of each should they use to end up with 42 liters of 20% butterfat? The names of the object are butterfat 24 as B24, B18, and B20. As for the amount of B24, let's substitute it for N. B18 has amount of 42 liter minus N. B20 has amount of 42 liters. For the value of B24, it has 0.24, B18 has 0.18, and B20 has 0.20. Then multiply again the amount and its value to get the equation. The equation are 0.24 times n for B24, 0.18 times 42 liters minus n for B18, 0.20 times 42 liters for B20. The equation derived from this data is 0.24 times n plus 0.18 times 42 liters minus n is equals to 0.20 times 42 4 times n, and multiply 0.18 to 42 liters minus n to have a product of 7.56 liters, and subtract it to 0.18 times n, then multiply again 0.20 to 42 liters to have a product of 8.4 liters. 0.24 times n plus 7.56 liters minus 0.18 times n minus 7.56 liters is equals to 0.06 times n and 8.4 liters minus 7.56 liters is equals to 0.84 liters. Now, let's find the value of n. To find its value, we need to divide 0.84 liters to 0.06 liters. And finally, n has a value of 14 liters. Therefore, 14 liters of the 24% buttermilk and 28 liters of the 18% buttermilk is needed. And for the example number 3, Noel is making a 65% antifreeze solution using pure antifreeze mix with water. How much of it should be used to make 70 liters? The names of the objects are antifreeze or A, water or W, and 65 solution. Their amount A, water has 70 liters minus A, 65 solution has 70 liters. Their values 1.00, 0.00, 0.65, and equations 1.00 times A, 0.00 times 70 liters minus A, 0.65 times 70 liters. The equation derived from this data is 1.00 times A plus 0.0 multiplied to 70 minus A is equals to 0.65 times to 0.70. 1.00A is equals to 45.5. A is equals to 45.5 liter. The amount of the antifreeze is 45.5 liters, and the amount of water added is 70 liters minus 45.5 liters is equals to 24.5 liters. And lastly, for our example number 4, what quantity of a 60% acid solution must be mixed with a 30% solution to produce a 300 ml of 50% solution? For mixtures name are A60, A30, A50. Their amount X, 300 minus X, and 300. And their value 60% is equals to 0.60, 30% is equals to 0.30, 50% is equals to 0.50. Equations 0.60x, 0.30 times 300 minus x, 0.50 times 300. To solve the problem, we have formed the equation below. 0.60x plus 0.30 times 300 minus x is equals to 0.50 times 300. Multiply each term by 10 or any multiples of 10 to convert the decimal to whole number. 6x plus 3 times 300 minus x is equals to 5 times 300. Then simplify. 6x plus 900 minus 6x minus is equals to 1,500. 3x equals to 300, x is equals to 200. Mixtures A60 has an amount of x equals 200, A30 has an amount of 300 minus x is equals to 300 minus 200 is equals to 100. A50 has an amount of 300. Therefore, 200 ml is needed for a 60% acid solution to be mixed with a 30% solution to produce 300 ml of a 50% solution.
Good day everyone. Today I will discuss on how to solve the distance, rate, and the time problem. To solve these three, we use the formula quantity equals rate times time and distance equals rate times time. For example, you are eating candies at a rate of 4 candies per hour for 5 hours. How many candies did you eat? Determine the quantity. Hence, quantity equals rate times time. Substitute the given. Quantity equals 4 candies over hour times 5 hour. Then cancel out the r. Quantity equals 4 candies times 5 is equals to 20 candies. So the answer is quantity equals to 20 candies. Another example is you have been on a boat for 8 hours and have traveled 56 miles. How fast is your boat going? We will determine the rate and we use the formula distance equals rate times time. Substitute the given. 56 miles equals rate times 8r. 56 miles over 8 hours equals rate. Divide 7. The answer is 7 miles over hours equals rate. And the answer is rate equals 7 miles per hour. Another example is you are biking for 40 kilometers at the rate of 8 kilometers per hour. How long have you been biking? The question is how long a certain biker is on the road, or we will determine the time using the distance formula. Distance equals rate times time. Substitute the given. 40 kilometers equals 8 kilometers over hours times time. Solve for time. Isolate it by dividing both sides by the rate. 40 kilometers over 8 hours over hour equal 8 kilometers over hour over 8 kilometers over hour times time. Cancel out the 8 kilometers over hour. The remaining is 40 kilometers times r over 8 kilometers equals time. And cancel out again the kilometer and the answer will be time equals 5r. Another example. This is different from the first three examples. Example. Mike leaves his house traveling 4 miles per hour. Joy leaves 9 hours later to catch up with him traveling 10 miles per hour. How long will it take her to catch up with him? Solution. Let's use the table to visualize the given, but please take note the formula. The formula is distance equals rate times time. Let t equals be the time of the faster person, Joy. The given rates are filled in. Mike's time is t plus 9, showing his 9 hours head start. You will see the table is Mike, rate 4, time t plus 9, and the distance of Mike is 4 times t plus 9. While Joy, rate is 10, and the time is t, distance is 10t. From the problem, as they cover the same distance, we will equate the equation for the column of distance. 4 times t plus 9 equals 10t. Let us solve the equation. 4 times t plus 9 equals 10t. Distribute the constant at the left. 4t plus 36 equals 10t. Combine like terms. 4t minus 10t equals negative 36. Negative 6t equals negative 36. Negative 6t of 4t equals negative 36 over negative 6 is equal to T equals 6. Hence, Joy catches up Mike after 6 hours. Number 2. Dan is rowing a boat and he can row 320 meters against the current in the same amount of time. It takes him to row 1,120 meters with the current. Dan rows 9 meters per second. How fast is the current moving? Solution. Let us identify the given and unknown from the problem. It is better to use table to visualize the given and unknown. But take note the formula. The formula is distance equals rate times time. Time equals distance over rate. Let x equals rate of current. The rate will be slower against the current, so we have the rate of 9 minus x. On the other hand, the rate with the current will be faster. Hence, the rate is 9 plus x. The table show is against the current. Rate 9 minus x. The time is 320 over 9 minus x. The distance is 320. With the current, rate is 9 plus x and the time is 1120 over 9 plus x and the distance is 1120. From the problem, Dan can row with and against the current with the same amount of time. Hence, we will equate the two equations for time. Hence, 320 over 9 minus x equals to 1120 over 9 plus x. Let's solve the equation. 320 over 9 minus x equals 1120 over 9 plus x. Cross multiplies, we have 320 times 9 plus x equals 1120 times 9 minus x. Distribute. 2880 plus 320x equals 10,080 minus 1120x. Combine like term. 320x plus 120x equals 10,080 minus 2,880. Then the answer is 1,440x equals 7,200. 1,440x over 1,440 equals 7,200 over 1,440. And then the answer is x equals 5. Hence, the current is 5 meters per second. And that's the end of my discussion. Thank you for listening.
Good morning to everyone. I am Arlene B. Maghari and today we will discuss our next topic, which is work problem. We have our 3 example here. The first example is Ernie can plow a field alone in 4 hours. It takes Sid 5 hours to plow the same field alone. If they work together and each has a plow, how long will it take to plow the field? To solve this problem, we go first, circle what you find, how long together. Work problems of this nature may be solved by using the following equation. Our equation is 1 over first person's rate plus 1 over second person's rate plus 1 over third person's rate equal to 1 rate together. Therefore, 1 over Aaron's rate plus 1 over Sid's rate equal to 1 rate together. 1 over 4 plus 1 over 5 equal to 1 over t, or time. 5 over 20 plus 4 over 20 equals to 1 over time. Now we find a common denominator on left side of equation. Then 9 over 20 equals to 1 over time. Now we use cross multiplying and will be equal to 9t equal to 20. Then solve for t, divide both sides by 9. 9t over 9 equal to 20 over 9. T equal to 2 and 2 over 9 hours. Therefore, it will take them 2 and 2 over 9 hours working together. Second example, two painters, Chris and Peter, working together can paint a house in 3 hours. Chris can paint the same house by himself in 8 hours. How long will it take Peter to paint the house working alone? This is the solution. Since Peter's rate is unknown, we let his rate equal to 1 over x. 1 over Chris' rate plus 1 over Peter's rate equals to 1 rate together. 1 over 8 plus 1 over x is equal to 1 over 3. Now we're finding a common denominator on left side of equation. It will be x over 8x plus 8 over 8x equal to 1 over 3. Then we'll apply the cross multiplying, which is x plus 8 over 8x equal to 1 over 3. On the right side of equation, distribute 3 on each term, which is 8x equal to 3 times x plus 8. Next is 8x equal to 3x plus 24. Then let's combine like terms. 8x minus the 3x equal to 24. Then we solve for x. 5x equal to 24 and 5x over 5 equals to 24 over 5. Therefore, the x equals to 4 hours and 4 over 5 hours. Therefore, Peter can paint the house in 4 over 5 hours or 4.8 hours. In our third example, an experienced carpenter can frame a house twice as fast as apprentice. Working together, it takes both of them 2 days. How many days would it take the apprentice working alone? Here's the solution. Let apprentice rate be equal to 1 over x. Rate of carpenter's rate be equal to 1 over 2x. 1 over carpenter's rate plus 1 over apprentice rate equal to 1 over rate together, which is 1 over 2x plus 1 over x equal to 1 over 2. Now we will find a common denominator on left side of equation, which will be 2. 1 over 2x plus 2 over 2x equal to 1 over 2x. Now we will apply cross multiplying, which will be 1 plus 2 over 2x equal to 1 over 2. On the right side of equation, distribute 2 on each term. 2x equals to 2 times 1 plus 2. Then we can combine like terms. 2x equal to 2 plus 4 and will be 2x equal to 6. After that, we 2x over 2 equal to 6 over 2. And then our x will be x equal to 3 days. Therefore, the apprentice can do the job in 3 days.
Okay, so this time, let's proceed to the motion problems. In the solution of motion problems, there are three quantities which should always be considered. A distance, rate, times time. Okay, we have a formula which is distance is equals to rate times time. In the given situation or example below, two planes leave the same airport of the same time and fly in opposite direction. The speed of the faster plane is 100 mph, faster than the slower one. At the end of 5 hours, they are 2,000 miles apart. Find the rate of each plane. Okay, in this situation, we're finding the rate of the plane. Faster plane, the rate of r plus 100, the time is 5, and the distance is 5 multiplied by r plus 100. Slower plane, rate, time is 5, and the distance is 5r. To solve the problem, add the two distances of two planes and equate it to 2000. Okay, 5 multiplied by r plus 100 plus 5r is equals to 2000. Multiply the 5 times r is equals to 5r. 5 times 100, which is 500. Copy the 5r and equals to 2000. So this time we add the 5r plus 5r, which is 10r, and then replace the 500 into the right side of the 2000. Okay, it will be 2000 minus the subtract of 2000 and 500 is equals to 15, which is rate is equals to 150 because we divided the 15 into 10. Okay, the rate of a slower plane is equals to 150 meter per hour, and the rate of the faster plane is r plus 100, which is 150 plus 100 is equals to 250 meter per hour. Therefore, the slower plane has the rate of 150 meter per hour, while the faster plane is 250 meter per hour. Okay, we have another example here. After 5 hours, both planes are 300 miles apart. One going 40 meter per hour faster. Find the rate of the slower plane using rate in meter per hour. Okay, a faster plane has the rate r plus 40, time is 5, and the distance is 5 multiplied by r plus 40. Slower plane is r, and the time is 5, and then the distance is 5r. Okay, we have a formula or the solution here. 5 multiplied by r plus 40 plus 5r is equals to 300, which is 5 multiplied by r equals 5r. 5 multiplied by 40, which is 200, plus 5r is equals to 300. Multiply 5r plus 5r, 10r. And then replace the 100 into the right side of 300, which is we subtract 300 into 100. Okay, we move the 200 into the right side of 300, which is we subtract 300 into 200. The answer is 100. 10r is equals to 100. We divided here in 100 into the rate of 10, which is the answer is 10 meter per hour. The rate of the slower plane is equals to 10 meter per hour.
So, we will proceed to the last topic under the chapter 5 problem solving, which is the money problem. So we have here our given example. A piggy bank contains 27 total, which is 10 centavo and 25 centavo coins. The coins have a total value of 4.95. Find the number of 10 centavo and 25 centavo coins in the piggy bank. So to understand the problem, we will identify the given and the unknowns. So for our given, we have 27, which is the number of coins in the piggy bank. The 0.10, one type of coin in the piggy bank, and the 0.25, the type of coin in the piggy bank. Let X be the number of 10 centavo coins and Y the number of 25 centavo coins. So to understand further, we construct the table below so we can see it in our PowerPoint presentation. Under the 10 centavo is X and under the 25 centavo is Y, which have a total of 27. Under the 10 centavo is 0.10 times X and under the 25 centavo is 0.25 times Y with a total of 4.95. So, from the table, we can create two equations into unknowns. X plus Y is equals to 27, which will be our equation 1. And 0.10 times X plus 0.25 times Y is equal to 4.95 will be our equation 2. So we can solve the equations by applying the elimination method or substitution method. We will apply the elimination method in this case. So we have X plus Y is equals to 27 will be our equation 1. And 0.10x plus 0.25y is equals to 4.95 will be our equation 2. Let us convert first the decimals of equation 2 in whole number by multiplying each term by 100 or any multiples of 10. So we will multiply in each term of equation 2, which will result to 10x plus 25y is equals to 495 will be now our equation 2. So for our elimination method, to eliminate a certain variable, we will follow the steps below. Choose a variable to be eliminated, say x in equation 1. We will multiply the opposite numerical coefficient of the x term of the other equation, which is negative 10, to each term of equation 1. Then add the two equations. So we will just follow the steps. So multiply negative 10 to each term of equation 1, which will result to 10x plus 25y is equals to 495. Then add equation 1 and equation 2. Negative 10x minus 10y is equals to negative 270 plus 10x plus 25y is equals to 495, which will have a total of 15y is equals to 225. So to eliminate, we will divide 15 on both sides, which will result to y is equals to 15 will be now the number of 25 centavo coins. To solve x, just substitute the value of y in equation 1. So x plus y is equals to 27. X plus 15 is equals to 27. X is equals to 27 minus 15. So we will have now x is equals to 12, which is the number of 10 centavo coins. So therefore, there are 15 25 centavo coins and 12 centavo coins. So we will proceed to our example 2. A coin purse contains 20 total of 5 cents and 10 cents. The coins have a total value of 1.35. Find the number of 5 centavo and 10 centavo coins in the coin purse. So to understand the problem, we will identify the given and the unknowns. So for our given, we have 20, which is the number of coins in the coin purse. The 0.05, one type of coin in the coin purse, and 0.10 type of coin in the coin purse. So let x be the number of 0.05 centavo coins, and y the number of 0.10 centavo coins. So to understand further, we construct the table below, which will be seen in the slideshow. So under the 0.05 centavo is x, while the 0.10 centavo is y, which have a total of 20. And under the 0.05 centavo is 0.05x, and under the 0.10 centavo is 0.10y, which have a total of 1.35. So we will devise a plan. From the table, we can create two equations in two unknowns. So our equation 1 will be x plus y is equals to 20, and our equation 2 will be 0.05x plus 0.10y is equals to 1.35. So let us carry out and check. We can solve the equations by applying elimination method or substitution method, just like what we did in example number 1. So we will apply also elimination method in this case. So we have our given equation 1 and 2. Let us convert first the decimals of equation 2 in whole number by multiplying each term by 100 or any multiples of 10. So we will multiply 100 in each term of equation 2, which will result to 5x plus 10y is equals to 135, which will be our equation 2 now. So to eliminate a certain variable, we will follow the steps below. Choose a variable to be eliminated, say x in equation 1. We will multiply the opposite numerical coefficient of the x term of the other equation, which is negative 5, to each term of equation 1. Then add the two equations. So we will just follow the steps. Multiply negative 5 to each term of equation 1, which will result to 5x plus 10y is equals to 135 is now our equation 2. So we will add equation 1 and equation 2. Negative 5x minus 5y is equals to negative 100 plus 5x plus 10y is equals to 135, which will have a value of 5y is equals to 35. So we will divide 5 on both sides to eliminate, which will come up to the result of y is equals to 7, the number of 5 centavo coins. Again, to solve x, just substitute the value of y in equation 1. So the value of y in equation 1 is 7. So x plus y is equals to 20. X plus 7 is equals to 20. So we will transfer this 7 on the right side, which will become negative. So x is equals to 20 minus 7, which will have a result of x is equals to 13, the number of 10 centavo coins. So therefore, there are 7 5 centavo coins and 13 10 centavo coins. So to check, substitute values of x and y to any of equations 1 or 2 above.